Every second, factories around the world churn out enough ice cream to fill dozens of Olympic swimming pools. And yet, almost nobody has seen what actually happens behind those stainless steel walls. What starts as simple milk from a nearby farm is about to go through a transformation so precise, so scientific, that one wrong temperature could ruin an entire batch worth thousands of dollars. This is the story of how billions of gallons of ice cream come to life. And trust me, it starts in a place far less glamorous than you'd expect. It begins with tanker trucks arriving before sunrise, hauling thousands of gallons of fresh milk and cream straight from dairy farms. But before a single drop enters the factory, it has to pass a battery of tests. Technicians check the fat content, the bacteria levels, even the smell, because contaminated milk at this stage could compromise everything downstream. Once approved, the milk is pumped into massive stainless steel silos, some capable of holding over 50,000 gallons at a time. Here's where things get really interesting. The milk, cream, sugar, and stabilizers get blended together into what's called the ice cream mix. But this mixture is dangerously unstable at this point. It has to be pasteurized almost immediately, heated rapidly to around 71 degrees Celsius, and held there for at least 25 seconds, killing off any harmful bacteria. Then, in a dramatic temperature reversal, the mix is instantly cooled down to near 4 degrees Celsius using massive plate heat exchangers. But cooling it isn't enough. This is the step most people never get to see. The mix now enters a homogenizer, a machine that forces the liquid through microscopic nozzles under extreme pressure, sometimes exceeding 2,000 pounds per square inch. This shatters the fat globules into particles so small they become invisible to the naked eye, which is exactly why ice cream feels smooth instead of greasy or grainy. Without this step, you'd be eating something closer to frozen butter chunks than the creamy treat you know. What happens next might surprise you. The mix doesn't get frozen right away. Instead, it's pumped into aging tanks and left to rest for up to 24 hours at refrigerated temperatures. During this waiting period, the fat and proteins reorganize themselves at a molecular level, allowing the mix to hold more air later and produce a creamier final texture. Skipping this stage would result in ice cream that melts too fast and feels icy rather than silky. Once the aging process is complete, flavorings and colorings are carefully measured and blended in, whether that's vanilla extract, cocoa, or fruit purees. Then comes the real magic, the freezing barrel. The mix is pumped into a continuous freezer, a rotating cylindrical machine that simultaneously freezes the mixture and whips air into it. This aeration process, known in the industry as overrun, is critical because without air, ice cream would be dense, heavy, and nearly impossible to scoop straight from the freezer. Inside this barrel, temperatures plunge to around -6 degrees Celsius in a matter of seconds, transforming the liquid mix into a soft serve consistency almost instantly. But here's the twist. At this stage, it's still not solid ice cream. It's closer to a thick, creamy slush. If chunks like cookie pieces, candy, or swirls of caramel are part of the recipe, this is the exact moment they get injected through specialized dosing pumps, ensuring they're evenly distributed without sinking or clumping. From here, the soft mixture is rapidly pumped into filling machines that shape it into pints, tubs, cones, or novelty bars, depending on the product line. Precision matters enormously here, because underfilling containers can violate regulations, while overfilling wastes product and cuts into profit margins. High-speed filling lines can package hundreds, sometimes thousands of containers every single hour. But the ice cream still isn't finished, not even close. This is where most people assume the process ends, but the real transformation is about to happen. The filled containers move into a hardening tunnel, an intense blast freezing chamber where temperatures can drop to -30 degrees Celsius or lower. Here, the soft serve consistency solidifies into the firm, scoopable texture you recognize from the grocery store freezer. This hardening process can take anywhere from a few hours to overnight, depending on the size and type of product. Throughout every single stage, quality control teams are relentlessly monitoring the process. Samples are pulled for taste testing, texture analysis, and microbiological screening. Metal detectors and X-ray scanners inspect every package to catch any physical contaminants before they ever reach a shelf. Nothing moves forward without approval. Once hardened, the ice cream enters cold storage warehouses kept below -20 degrees Celsius, waiting to be loaded onto refrigerated trucks. From there, it begins a carefully coordinated journey through the cold chain, a logistics system engineered to ensure the temperature never rises high enough to compromise texture or safety, all the way until it lands in your local store. Think about that for a moment. What started as simple milk from a farm, tested, blended, pasteurized, homogenized, aged, frozen, filled, and hardened, went through dozens of precise engineering steps just so you could enjoy a single scoop on a hot afternoon. It's a process most people never think twice about, yet it represents decades of food science and industrial innovation working together seamlessly. If this journey from farm to freezer fascinated you, make sure to like this video, drop a comment letting me know what factory process you want to see next, and subscribe for more incredible manufacturing documentaries just like this one.